Hi, Abu Bakar.
Hi, ma'am. Good evening.
Good evening. We'll wait for 2 minutes.
Ma'am, I wanted to ask you a question. Was there a class yesterday?
Was there?
Did the class take place yesterday? Because I did not see the recording.
There was nobody. No. I waited for 15 minutes. You had informed, but nobody else also informed. So I just waited and I left.
Okay.
You had sent a message, but
Yes.
in the last class we had done refraction. It was last week. Could you remind me what did we do in the last class?
And we did refraction of light.
Yeah, so we did refraction of light. Today we'll continue. So we'll do the laws of refraction of light. Can you see my whiteboard?
Yes, ma'am.
Okay. So the first law of refraction of light is very simple. It is exactly like the first law of reflection of light. So this says that the incident ray, the refracted ray, and the normal lie on the same plane. Same plane means same side.
Done, ma'am.
The second law of refraction gives the relationship between the angle of incidence and the angle of refraction. This is called Snell's law because it was discovered by Snell. Have you done trigonometry in mathematics? So the sine angle of incidence to the sine of the angle of refraction is a constant, and this constant is known as refractive index of a medium. You have done trigonometry, right? Yeah. So this sin I by sin R is a constant which is called the refractive index of a medium. And this refractive index of a medium is denoted either by n or mu. Some books it's mu, some books it's n. And because refractive index is a fraction, it will have no unit. So what does the refractive index mean? The refractive index means the light bending, how much the light will bend, it gives that capability of that medium.
Ma'am, what is the constant for the refractive index?
What is the?
Constant.
That value of the constant is refractive index given by small n or mu.
Okay.
The name of the constant is called refractive index of the medium. It gives an indication of how much the light will bend.
Okay.
Done?
Ma'am, wait, last two lines.
Okay, okay.
Done, ma'am. Done.
Done? Okay, one question. A beam of light passes from air into a substance X. If the angle of incidence is 72 degree and the angle of refraction is 40 degree, calculate the refractive index of mid substance X. So refractive index of X sin I by sin R. So sin 72 degree by sin 40 degree. To the calculation, it is a ratio so that it will not have any values. No units of measurement.
So ma'am, we get the value as 317 divided by 214.
1.48.
Yes ma'am, 1.48.
Okay. Now, because the refractive index is connected to the speed of light, I'll show you how. So refractive index gives an indication of how the light bends, right? So suppose I have, first draw this diagram. Suppose light is entering from, say, air to water. Okay, so light is entering from medium 1 to medium 2. Draw this diagram first. So which means that the refractive index of medium 2 with respect to medium 1 is nothing but, so the refractive index of medium 2 with respect to medium 1 is nothing but the ratio of the speed of light in medium 1 to the speed of light in medium 2. So we write it in this way. So n to 1, this is written in this way.
Done ma'am.
Yeah. So when light is going from one medium to another and the other medium is air or vacuum, that is called relative refractive index. When light is going from vacuum to another medium, we call it the absolute refractive index. So basically, if it is with respect to air, even then we call it the absolute refractive index. The ratio of light, the speed of light in vacuum to the speed of light in a medium is called refractive index of that medium. And this can be air also. It can be air also. It can be vacuum also. It's the same thing for us.
Ma'am, can you go up a bit?
Huh?
Can you scroll up?
Yeah, sorry.
Done, ma'am.
Done. One question. Light enters from air into a glass plate having refractive index 1.5. What is the speed of light in glass? Okay. So we know that refractive index is nothing but the speed of light in air or vacuum divided by the speed of glass. Very, very simple if you know the formula. Now do it yourself. I think you can do it. Just substitute the formulas.
And the answer will be 2 into 10 to the power of 8 meters per second.
Correct. Now, the refractive index also depends on the nature, on the material of the medium and also on the wavelength of light used. So different colors will have different. So what is the meaning of this? What happens when it is a high? Achha, what will happen if two medium are, optically the same? So then there will be no bending of light. Optically the same, meaning the density of the two medium will be the same. So there will be no bending of light. A medium which has higher refractive index is said to be optically more denser. And what does that mean? So which means there will be more refraction or more bending of light. Higher the refractive index, greater will be the bending of light.
Ma'am, can you scroll up a bit?
Yeah, sure. हाँ, क्या ये लगाना था ना, इधर नहीं, आप उधर 1 minute, give me a minute, उधर से लेना। প্লাগ পয়েন্ট চলছে, এটাতে না, এটা অবশ্য কাজ করে না, ওটা তো ওই জন্য সরিয়ে দিচ্ছি। Hey, Abu Bakr, just give me a minute. Just 1 minute.
Okay, ma'am.
No, no, no. Daro. এক second, Daro. Dharo. Just give me a minute. Just 1 minute. Huh. Just give me a minute, okay? Some work going in the house. 1 minute. One. Done.
Done, ma'am.
Okay. Now I will show you that the refractive index of light going from medium 1 to 2, okay, is equal to the reciprocal of the refractive index of light going from medium 2 to 1. Simple derivation. So I have got two figures. I will show you two figures. One is a figure of light going from medium 1 to 2, which is figure 19. And the second figure is the ray of light. So here, this is medium 1 to medium 2. V1 is the velocity of light in medium 2. V2 is the velocity of light in medium 1. And here it is going from medium 2 to medium 1. And here the arrow is this side. A simple derivation. First draw the picture and then I will show you. So let the speed of light in medium 1 be V1 and the speed of light in medium 2 be V2.
Done, ma'am.
Done. So basically, so the speed of light in medium 1 is V1 and that of medium light in medium 2 is V2. So therefore, the refractive index of medium 2 with respect to 1 is V1 by V2 and the refractive index of medium 1 with respect to 2 is V2 by V1. So simply we can just take the reciprocal and then we can say that we can prove it. So 1 by, so this. It is simply the reciprocal, nothing to do here.
Done, ma'am.
Done. Try this question. If the refractive index of water for light going from air to water is 1.33, what will be the refractive index for light going from water to air?
Ma'am, it will be 1 by 1.33.
Yeah, it will be 1 by 1.33, which is here you will write it in this way. 0.75 is the answer, right?
Done, ma'am.
Done.
Yes.
Do this. These are all your NCERT book questions only. Do this. So in which material does light travel the fastest?
Water.
Yeah. So basically, write it in
The
this
refractive index is equal to the speed of light divided by speed of kerosene, and that.
speed of light in air divided by the speed of light in the medium. So therefore, the light having the maximum speed in water, so the light will travel the fastest in water. Correct. Done.
Yes, I'm done.
Now we'll start up with lens. This is the main part of the chapter. Okay. So lens is basically a surface. So lens works on the principle of refraction. So lens works on the principle of refraction of light. And a lens will have two spherical surfaces. So lens is nothing but a transparent glass which has two refracting surfaces or two spherical surfaces. So just like we had spherical mirrors, just like that, we have convex lens and we have concave lens. So a convex lens is thick at the center and thinner at the edges. And a concave lens is thin in the middle and thicker at the edges.
Done, ma'am.
Okay. The first parameter that we will study is the optical center, which is the center of the lens. And the principal axis is a line passing through the optical center of the lens. So the line passing through the center of the lens, exactly like a mirror, is known as the principal axis.
Done, ma'am.
Okay. Now, the principal focus of a convex lens, first we will do convex lens and then we will do concave lens. So is a point on the principal axis where the rays of light, which are parallel to the principal axis, pass through the focus. So here, if you notice, there are two focus. They are called two foci, and there are two focus. You can see here, F and F dashed. So every lens will have two focus, and two focus, it's called foci. So two focus, both of them will be on each side of the lens. Why? Because the lens has two refracting surfaces. And the focal length is nothing but the distance of the focus from the optical center or the center of the lens. Optical center is the center of the lens. So a convex lens is also called as a converging lens. Why? Because you can see the rays of light after refraction, they converge to a point or they meet at a point. So convex lens and concave mirrors behavior is similar.
Done, ma'am.
Done. Let's just finish at concave lens. So this is the picture of the focal length of a concave lens. So the principal focus of a concave lens is a point on the principal axis. It's all virtual, but the rays of light appear to, originally parallel to the axis, appear to diverge. And therefore, the concave lens is known as a diverging lens. And we'll stop here for today.
Done, ma'am.
Done. We'll stop here for today. We'll continue in the next class. Thank you. Thank you.
Thank you, ma'am.
Bye. Bye.